to walk you through my process of powering up this incredibly advanced, self-designed, all Garmin IFR avionics installation in this RANS S21. For more information on the specific components and the wiring process, see my 2 previous avionics episodes linked in the description. Now, as with most of my build episodes, there's a long form version, and in this case, you'll see me configure the vertical power system, the G3X Touch and Autopilot, and the GNX 375 Navigator. What's unique about today is you'll see how I use my experience as an Air Force operational test pilot to methodically walk through this huge milestone in this build. Now, as a first-time home builder, I don't have any build skills that I will tout. I'm sure most of you agree. But I do have a methodology and attention to detail that I hope has served me well in wiring this and will avoid melting down my airplane in avionics in my shop, which is my house. If I can do that, you'll see me apply the same methodology to my first engine start, taxi, and eventually flight test this spring. One asset that I've had lately is time. My engine is still a few months away from being delivered, so I've been able to pace myself. Now, I do have some news regarding the Continental Titan engine delivery timeline that I'll pass along at the end of the video. So when writing a test plan in the F-15, we'd establish test objectives, limitations, safety measures, a validation and verification, or val-ver period, and we'd develop test points, which of course are the meat and potatoes of this video. So let's get into each of those for today's avionics power-up test. All right, so the test objective is to safely test the entire electrical system for integrity and communication, identify faults to correct any issues to enable me to move on with the remainder of the build. There are some limitations. The test limitations are engine and wing-mounted sensors devices, pitot-static system, pitch, trim, and audio. Okay, so we've got some safety measures in place. I've validated all my schematics. I've verified continuity through many, many hours of shooting wires with a multimeter. The power cables contacts are clear of any shorts. Any unterminated power cables are insulated. Antennas are connected, which is important for powering up the GNX 375. The batteries are charged. There's a fire extinguisher nearby. And I'll always be within reach of power cutouts. And finally, I'll use the wingman concept. In this case, my wife will be here insulated by not touching any part of the airframe at any time and be ready to help. So the phase 1 test points, which I like to think of as tactical objectives, are number 1, backup battery system power up. Number 2, configure the vertical power system, which is the VP-X Sport, with the switches and buses including circuit breaker values. Since this is a solid state system and highly configurable, this is a vital first step before powering up the main system. Number 3 is to safely power up the master switch battery bus. Test point 4 is to safely power up the Avionics Bus. And then lastly, we'll safely power up the accessories bus. Okay, then we'll get into test point 6, which is updating firmware, and then we'll configure communication ports to get each LRU to communicate with each other. They talk in different languages, so we need to specify all that. Number 8, the last test point, is to observe individual bus loads on the vertical power screen to ensure proper circuit breaker values are set and wire gauges are installed. Now, once I have all this data, I'll be able to address any faults and tidy up the harness by installing spiral wrap and securing bundles, especially where they're near flight control cables or potential chafing areas. All right, briefing is complete. Let's do this. I am very nervous, but also super excited. Fingers crossed. Whew, I can't believe this is happening. Okay, test point 1, backup battery. Safety measures in place. What's wired here is G3X Touch, GNX 375, and then all the sensors. So with any luck, these two will power up, and then we'll go see if the blinking LED lights on the GAD 29, GSC 25, and GEA 24. That's a good sign. That's a good sign. That's a fantastic sign. All right, let's go check the blinking lights. GSC 25 on the back of the G3X Touch. The out of harness unit is blinking. Let's check. I do know that the GEA 24 engine monitor has one, and yes. And GMU 11 way back in the tail. I'm not gonna mess with that yet. But the way we'll be able to tell if those have power and communicating is eventually when I power up the G3X touch or all the, when I program all the ports, if they're talking. And in fact, that shouldn't even be necessary because the GMU11 is just on the CAN bus. But one thing at a time. Okay, so test point 1, we'll call that a success. On quickly into test point 2. I'm gonna wait, I'm gonna just make sure I don't smell anything. I'll kind of feel the backup battery, make sure it's not hot, no smoke. It's fantastic. Test point 2. So without the backup battery on, we're just gonna turn this on to give power to the vertical power system so that we can configure it. A couple things to note is you've got to have a Windows laptop. I do not have a Windows laptop. I'm borrowing one from my friend Yuri, thank you. And it has to be relatively new. I think they support it back to Windows 10. Vista, XP, all those things, not so much. And then the other thing to note is you have to have administrator privileges. And then number 3, you've got to have a crossover Ethernet cable. A normal Ethernet cable won't work. Crossover just reverses all the ports. So things like networks can talk to each other. So crossover, and that comes with the VP-X Sport. We've got the laptop powered up. I've got the vertical power configurator software loaded, as well as I've downloaded the file that I created on Vertical Power's website that configures all the switches and circuit breakers. So everything should be ready to go. Let's get plugging it in and try to configure the vertical power. See? Yep. Yes. Good news. That has power. No weird sounds, no smoke. We can configure the vertical power. So, okay, good. So device configuration, starter, 10 amps, GDU 460. I don't know why there's a /4 there, but always on, that's good. Alternator field should be switched. That's switch 1. I'm gonna only have one electronic ignition go through the vertical power. The other one is gonna be direct to the battery. Strobes. This one doesn't look like it's used. Okay, so this is gonna be switch 3, which is Avionics master. Landing light left. All right, the backup battery, as well as the flow-through battery to power the GNX 375 and sensors. Backup power. COM1. COM2. COM2 is unique because it has both the audio panel and radio 2. And it's assigned to Avionics Master so that I can load shed. I may change my mind and put COM1 on always on, but I just like to be, you know, these days you can just call on your cell phone if you're having an Nordo situation. All right. Autopilot, definitely want to be able to turn that off. If I had another switch available, I would probably put that on a switch, but I didn't. Pitot heat, 15 amps. Landing light right. Fuel boost pump, 10 amps. Sensors, 2 amps. G5, 1 amp. Nav lights, 1 amp. Cool. So the way the fault detection is, how that works is that if the switch is on and it's expecting to see a load and it doesn't see a load, it'll report a fault. But while you're testing on the ground, they advise to just have it turned off, and then once you get ready for flight test and whatnot, you can turn on fault detection. Okay, that all looks good. No secondary alternator. Okay, wigwag, we're gonna set that speed to 0 at first, and we're just not gonna mess with it yet. Pitch trim, we'll have to set that up. Flaps not applicable. All right, device status. Cool, and it's, so 1.3 amps on that, 1.2 amps. 0.4 on the sensors, 0.2 on the G5, good. So there's load. All right, this is charging, so 3.9 amps there. And then flow through power for the GNX 375 is not turned on. There's 0.1. That'll probably bump up when I turn on the Avionics master or the battery backup switch. All right, system status. EFIS data missing. I might have to tell what kind of EFIS it is. And we can simulate data, and then there's a log. Great. All right, so far so good. I'm gonna put the camera down and just go through this one more time. Now that the vertical power system is configured with circuit breakers and switches, etc., the next time I power up this switch, we should get potentially the GNX 375 if the flow through the backup battery is working, but the G5. Those are the two things I'm really looking for. Come on. Yep, GNX 375, G3X touch, and yes, we've got power to the G5. Okay. Everything else on the right side is going to be on the Avionics master, so that'll be the test point 4. But right now, we're just doing this methodically, not getting too far ahead of ourselves, waiting for any sort of smoke or weird sounds. Nothing looks too bad. No big warnings anywhere. Before I power up everything else, I want this to know that it's working with vertical power. So we have to tell the G3X Touch that it's got a vertical power system. So I believe the way you do it is to get into config mode. So let's turn everything off. And then just give it a second. And then when you power it back up, we're gonna hold the menu button. There is a lot to configure, as you can imagine, in this system. Configuration mode, good. All right, software version 8.6. I can't remember off the top of my head what I have right here, but I have downloaded from Garmin the latest software firmware updates, as well as they give you one free database update. It obviously comes with a database, but I think it's old. So when I get closer to flying, I'll activate that and update the database. After that, then it costs an ungodly amount. All right. So good, it is communicating with the GMU11, the GEA24, the GAD29, the G5, and of course itself. So that is telling me that the CAN bus is good. It's communicating with everything. So that is great. And again, the only red X here appears to be just because it doesn't have a feed from the outside air temperature. I could test it, hook it up, but that's beyond the scope of this for right now. Okay, cool. So how do we go back? Menu, or actually there's a back button. Cool. Forgive me, I had to re-record this. A couple issues, no big deal. Go to set up the vertical power, to tell the G3X Touch system that this is powered by a vertical power system. Go to your RS-232. We'll get to configuring all the ports here in the next couple test points. But I do want to go to the screen now because that was a big part of this test point, which is telling the G3X Touch it is powered by vertical power. So whichever port it's plugged into, the G3X Touch, which in my case it's port 3, RS-232 port 3, select all the way to the bottom, oops, vertical power. Once you select that, now you have all the magic that the vertical power brings to be able to monitor buses and amperage, which we'll get to later in the video. So now that that's set up, save and reboot. All right, let's get on to the next test point, which is powering up the Avionics Master System. This is kind of a big one. So this includes a couple of mini buses. I've got COM1 minibus, COM2 minibus, which include the two LRUs back there, GTR20 radio and GMA 245R, as well as the autopilot system on a bus. So that's the GMC 507 and the two autopilot servos, as well as the G3X Touch on the right side. Okay. Heard clicking. I'm seeing radio power up. I'm seeing G3X Touch. I've got power on the GMC 507. I've got green flashy lights on the roll servo. Let's check it on the pitch servo. Yes. Awesome. Whew. Okay. I don't know. Are there green flashy lights Back here, it's hard to see. Ah, there's one. Okay, so far so good. Whew. If everything is still working well. I suppose another test point I should figure is turning on the master or the battery backup to see if that integrates well with everything. But let's just wait. We'll continue on with test point 5. Oh, that's so great. Okay, let's try accessories. Yes! Those are so bright. I can't dim them, but I can turn them off. This is so exciting. Everything appears to be working. Oh my gosh. Okay, with accessories on, that USB charger should work, so I guess I could test that. USB Type-C to Lightning. Of course, I'm recording with my iPhone, so I'll go grab my iPad. And then USB-A to Lightning as well. Oh, except my iPad is USB-C, so. Okay, I've got USB-C to C, so let's swap out this Lightning cable because I've got my iPad here. Of course, the Bible pulled up. One-handed. Charging. Yes! All right, let's test the manual reversion. Here we go. Yes! All right, nothing changed here, so that just makes that a backup. Back to MFD mode. Oh my gosh. This is so exciting. Okay, I wonder, so let me change the altimeter here. Oh, yep, it changes right there too. And then this is ident, so let's go into this mode. Couldn't see anything. Oh, let's try to transmit. Transmit, receive. Oh my gosh. Okay, heading track. Let's see if I can. Oh, yep, this changes heading, at least on the PFD. And then altitude select. Yep, changes the altitude alerter there. I push it, it slaves back to current. Heading should slave back to current. Oh man, there's so many settings to go into. What's great about this system is the G3X will update all the LRUs on the CAN bus when updating the firmware. This means that the GNX 375 will need its own update. Now, if you can tell me in the comments why the GNX 375 isn't CAN bus enabled, I will thank you in my next episode. So to load the firmware on the SD card, unfortunately you need a Windows machine. Ironically, the Windows laptop I had was unable to format the SD card to MS-DOS FAT32. So believe it or not, I had to use the disk utility on my Mac to accomplish that. But once it was formatted, it was easy to load all the LRU's firmware onto this SD card. It took about 10 minutes in all before I moved on to the GNX 375. Okay, so that's done and powering back up. So AFCS software, I assume that's autopilot, auto flight control system. Oh, yep, they just clicked. Ah, red light. Green light. Okay, that's interesting. So I've got trim indication right there, but not on the MFD. So that's probably a factor of that having older software. Yeah, I guess I should point out that the other G3X touch screen needed its own version of that software. So I just moved the SD card over and loaded that. So I'm not sure why, if it can load all sorts of other LRUs, why it doesn't update the firmware on the other G3X touch screen, but that's what you got to do. All right, before I put you guys to sleep even more than I already have, even you long-form troopers, I sure appreciate you. I'm going to speed this up here. Let me know in the comments if you're interested in all this stuff and how I configured everything. There are some tricks that I learned, some things that I stumbled on along the way, but the bottom line is everything is working. We'll get into some things when I wrap this up that aren't quite working yet, that I haven't quite figured out, but they're so minor. It's the ident button and a config module within the transponder. So suffice to say, I went through all these screens. I configured the RS-232 ports. And then I configured the ARINC ports, and then also some discretes on the GEA24. So there's, 4 discretes, and then there's a bunch of general purpose. I did the discretes. I used all 4 of those because they're very, very simple. It requires 1 pin, whereas the general purpose ports are kind of like, an analog port that if you're telling it something digital, it needs a what's called a pull-up resistor to just have no middle ground, either a ton of impedance or no impedance, essentially. So I won't get into that, but let me know in the comments if you are interested in a full video of all the configuration pages, and I'll get to that. But let's move on to test point 8. I do want to see the electrical system now that it knows it's vertical power. Now I'm seeing vertical power show up. So let's go to that screen. This is what makes you money on the vertical power, what all that extra money buys you, I guess is a better way to put it. So this is where you're getting away from the circuit breakers and where you get into your electrical system. So here's a good example. On my Avionics master bus, let's go ahead and power that up. So on the Avionics master bus, I have the autopilot system, which I can keep everything else on the bus, but if the autopilot is acting funky or for my first few flights, I can actually deactivate that system. So look, so the GMC 507 turned off as well as the servos turned off. So, but yet I can have everything else on that bus. It's not technically a bus because this switch doesn't turn on everything, but the VP-X is configurable such that this acts like, hey, this is one bus, but now you can federate it into other systems. So COM 1 is just radio 1, so I can turn that on and off. Boom. Turn it back on. Now COM 2 is my remote GTR 200 or 220R, as well as the audio panel. So if I am having issues there, I can manually turn that off. Electronic ignition 2, I can manually turn that off because I'm only going to have one hooked up through the VP-X, the other is directly hooked up to the battery. Okay, I'm noticing something here. Remember we set up the low fuel alert for it's an active low for the header tank. There's a little switch, just a float switch in the header tank, which grounds out, so it's an active low, and that's working perfectly right now because I have no liquid in the header tank, so it is showing me red, low fuel. And then I can pull the circuit breaker if you want for the fuel boost pump. So that's off right now. That is hard switched, so that's showing off. I could turn it, if this switch fails, I can turn it on and turn it off right there. I'm not going to because there's no fluid in the system. Okay, the G5 is on its own pin, so I can manually turn that off even though it's on the Avionics master bus. I can turn the GDU 460 MFD, the EFIS 2 over there, I could turn that off. I could turn this display off, and then I can access everything over there. And then landing light left, landing light right, I can turn those on and off manually, as well as nav lights, but I've got all those on switches. So nav lights, pitot heat is on a switch, and then sensors. So without having nav lights hooked up and without hooking a multimeter up to my cable, it's just insulated with some electrical tape, so I can safely throw the switch. So let's go ahead and throw the switch over here and see if this check mark does that. So nav lights on, and look at that. And now let's check pitot heat. Pitot heat, good. So we verified that that's working. Let's go landing lights. Hopefully both of those turn on. Good, both of them turned on. And you'll probably be able to see, after I've configured the wigwag, especially in test mode at 0 knots, which we are right now, we could probably see them alternating. But let's turn those off. And then the other switches, the map is the manual reversion, which I showed, and then the cockpit lights, I haven't wired those up. Those are gonna be direct to the battery. Okay, sensors bus, I can turn off the main power to the sensors. I say main power because each of the sensors has a backup power input, which is powered by the backup battery. I don't want to turn those off. Starter, I'm not sure why that's showing a green check mark. clearly the starter is not on right now. So let's turn it on and see what happens. There should be an annunciator right there. Starter engaged. And starter off. Oh, strobes. Let's check that one too. Great. So that system is working. As well as, again, you can see the amperage of each. If there's an amperage being pulled, you can see how much in that individual circuit, I don't want to say bus because each individual circuit is pulling. So as part of the test points, I want to take note of all those with them powered on, not the lights, of course, because there's no load currently, but see how much amperage everything is pulling and verify, A, I have the correct circuit breaker value set up within the backside of the vertical power. And then also, B, I want to validate that I have the correct gauge of wire, right? Just bounce it off the advisory circular 13 whatever it is to ensure that, you know, with it being 14-volt system, with the length of wire that I have the correct gauges. I already have a spreadsheet of everything that the documentation from each device gave me, but I want to bounce it off of reality and check it here. G5's not pulling much. I don't have the backup battery on the back of the G5 installed yet. That would probably be pulling more until it recharges everything. Oh, something that caught my eye is you do have to have two separate power inputs, technically like 4 different power inputs into the backup battery. One is for main charging and then the 3 flow-through ports. So that's pulling 3.8 amps right now, even though it's off, so it's charging it. So let me turn that on and I want to see if potentially that starts pulling amperage there. No. What I could do is turn off everything and then, hey, let's do that now. Let's turn off the Avionics master, so the right side of everything here. And then what I'm going to do is I'm going to turn off the master battery and see if now, of course I'm losing all my LRUs, right? Let's see what happens here, because this should remain powered. It's going to switch over from main battery power to backup power when I turn off my master battery switch. Okay. So it's still showing 3.7 amps there. Okay, so the vertical power shuts down, so you lose that. That's good to know. The other thing that I want to test eventually once I get the horizontal stabilizer and trim servo installed is that if I power off everything, including the autopilot system, will the trim still work? It's wired to. The trim does go through the autopilot system, but if it's off or has a fault, it should pass power straight through to the servo. You might not get an indication, but you should still be able to power it. Okay, so that's a test point I'll have to add later. So what fighter pilot debriefing would be complete without a tie back to the mission or test objective? So yes, I'd say we absolutely conducted a safe test of the entire electrical system, what we could test for integrity and communication. We identified faults to correct issues to enable me to move on with the remainder of the build. So needless to say, I am blown away by the success of this test. I have a few very minor items to address, such as the ident button and transponder config module fault, but overall, this was a resounding success, and I do have a few people I'd like to thank. First off, Jess Veruta of New View Technologies in Oshkosh, thank you for patiently teaching me the fundamentals of wiring this CAN bus-based system and being my wise consultant along the way, and also my friend. Thanks to Chad at Vertical Power for validating my VP-X sport configuration plan, and finally Bob with TCW for validating my very non-standard backup battery plan so I can divert power from backup avionics to one of my electronic ignition systems with a single battery. In short, it involves strategically placed diodes to ensure current flows to where it needs to go in case of an engine out emergency and doesn't backflow charge to the main battery. Okay, I'm still developing phase 2, 3, and 4 avionics test points, but they'll include such items in phase 2 as RFI versus GPS interference test, the magnetometer and ADAHRS calibration, transponder and ADS-B test, pitch trim tests with autopilot servos on and off, ELT test, and audio tests including oral alerts, 3D audio, Bluetooth music. Now phase 3 will be airborne, PIDO and AOA calibration, RNAV performance on a VMC instrument approach, ADS-B out validation, and comm strength. Phase 4 will be autopilot calibration with adjusted pitch trim, and then electronic stability protection calibration resulting in an automated upset recovery and IFR certification. So that's going to be super fun. Listen, don't let the complexity of this installation and test intimidate you from wiring your own avionics. I encourage you to be methodical and take your time learning and reading your installation manual and other great resources such as the Aeroelectric Connection. And perhaps most importantly, validate your plan with somebody who knows more than you do. This was by far the most enjoyable part of the build so far. And I'm eager to tidy up the wires, close out the cockpit, and get the wings on in my beautiful new hangar/studio that'll be done at the end of the year. I am developing a way to share all my planning documents, schematics, design files with you, but I gotta make sure the legal I's are dotted and T's crossed, along with some other fun announcements, but that'll happen at my next YouTube milestone, which is an astounding 10,000 subscribers. So look for that coming in the next few months. I'm also traveling to Italy to meet my paint designer, Mirko Pecorari, in person after working with him exclusively in VR space.
And as an Italian, you know, we speak with the gestures, so I'm teleporting everywhere.
So I'm super excited for that, bringing Ani with me, of course. Now, for the Continental engine update. I ordered my Titan IO 340 on February 25th, 2021. That's 2 months before I even received my kit to start this build. If it was a child, it'd be walking and nearly talking by now. That's 19 months. The holdup is obviously supply chain issues, most notably nickel silicon carbide, the alloy that provides good corrosion resistant properties to the cylinders. If you live in a dry environment and fly a lot, you can get hardened steel cylinders and you'll get your engine in 2 weeks. Heck, you can even coat the inside of the hardened steel cylinders during a top overhaul. Call me crazy, I'm sticking with the NIC3. At Oshkosh, the CEO of Continental Motors promised us an update.
After August, we will announce the new lead time will be significantly improved.
Well, it's nearly the end of September, so I reached out to RANS and they replied with this email from September 19th. Jamie Stutterheim said, I still haven't seen an NIC3 plated engine, but I have been assured that they have about 12 engines worth of cylinders in different phases of the build process. I was supposed to see 2 engines in September for RANS kit customers, but we are almost to the end of the month and I haven't seen a thing. I emailed Titan last week and I told them it didn't look like they were going to hit the mark they gave me. He agreed, but said it does look like they'll be able to get us 4 to 6 engines in October, and they plan on supplying us with 4 to 6 engines a month beyond that, if not more. You are still number 15 in line, which at 4 to 6 engines a month starting in October, you should have a 2022 delivery if they can meet the goal that they're setting. I have a few more people switch away from NIC3 plating, but most of them have been pretty far down the line. When someone switches, I'm seeing those engines within a week or 2 at most, so production is moving along. I'll have to see how many engines I receive in October to really gauge timelines. Now, when have they ever, in the last, 2 years, met a timeline? That's my concern. My other concern is I'm really trying to make it to Oshkosh 23. Fingers crossed, sounds like that will happen. My third concern is that I remain ahead of Ruben in line for a Titan motor. All right, brother, and everybody else. It's been a pleasure talking about this. Clearly, I'm very passionate about that. I really appreciate you humoring me and sitting through my mythology. Hopefully it helps. Hope it wasn't too boring. Until next time, you're clear to wreck.